Hello everyone, I'm Jivika Kancharla and I'll be explaining you guys the first question of the homework 3 of the course Probability and Stochastic Processes. As you can see, this is the question that is given to us. So let's go through the question. Let B probability of x is equal to k will be equal to b dot k dot p power k minus 1, where k is equal to 1 to infinity and the value of p lies between 0 and 1. Now in the first part of the question we are asked to calculate b, so that probability of x is equal to k will represent a probability mass function. So let's look at the solution. As given in the question, the probability of x is equal to k will be equal to b dot k dot p power k minus 1, where k is equal to 1 to infinity and p ranges between 0 and 1. Now to find b, we know that the probability mass function is equal to, but probability of x is equal to x will be equal to f of x. Now this can be represented in this way as given in the formula. Now when we write this, we elaborate this equation, we will get that b1 p power 0 plus b2 p power 1 plus b3 p power 2 and so on. Now we know that this whole function will be equal to 1. Therefore, as we separate this equation and write it and rearrange the equation, we will get this one. And according to geometric progression, we can rewrite the above statement as b of p power 0 by 1 minus b plus b of p power 1 by 1 minus b plus b of p power 2 by 1 minus b and so on till 1. Now if we calculate and evaluate the equation, we will get that b of p power 0 plus p power 1 plus p power 2 and so on by 1 minus b is equal to 1. Now once again, using geometric progression, we know that p power 0 plus p power 1 plus p power 2 and so on will be equal to p power 0 by 1 minus b. Therefore, substituting this into this equation, we will get the value of b into p naught by 1 minus b by 1 minus b is equal to 1, which is equal to b of p naught is equal to 1 minus b whole square. Therefore, the value of p will be 1 minus b whole square. In the second part, we are asked to evaluate the value of ex. So let's do that. E of x will be represented as e of x into pi. We know that probability x is given as p of x is equal to k. Now if we write this, it will be b into k into p of k minus 1. Since there are two k's, it will be k square into b into p of k minus 1. Now from the first part, we know that p is equal to 1 minus p squared. So we'll substitute that here and we'll take summation for only this part, that is k squared p power k minus 1. Now since we know that p power k, as from the geometric progression, that summation p power k for k is equal to 1 to n is equal to p power 0 by 1 minus p, which is equal to 1 by 1 minus p, since p power 0 is equal to 1. Now if we differentiate this on both sides with respect to p, we will get the value as summation from k is equal to infinity, k into p power k minus 1 is equal to 1 by 1 minus p square. Now once again differentiating it on both sides with respect to p, we will get summation p power k minus 1 into k squared is equal to 1 plus p by 1 minus p cube. So let's substitute this value into this equation here. Therefore, summation k is equal to 1 to infinity b into k square into p power k minus 1 will be equal to b. Let's take the b out since there cannot be no summation applied. So b into summation k is equal to 1 to infinity k square p power k minus 1. Now this value we committed from here. So b into 1 plus p by 1 minus p cube. And we know from a that b is equal to 1 minus p whole square. So let's substitute, and then if we solve, we will get e of x is equal to 1 plus p by 1 minus p. Now in the third part of the question, we are asked to calculate e of x square. So e of x square is equal to e of x square into p of x is equal to k. And once again, we know p of x is equal to k is equal to bk into p power k minus 1. Therefore, it will be equal to summation k is equal to 1 to infinity k cube into b power b into k p into k power minus 1. Now, if we take the b outside, it will be summation k is equal to 1 to infinity k cube p power k minus 1. Now, from the third equation in b, that is from this equation, we already know that summation k square p power k minus 1 is equal to 1 plus p by 1 minus p whole cube. Now, if we differentiate on both sides with respect to p, we will be getting this value, which is our required value, that is summation k is equal to 1 to infinity k cube into p power k minus 1 is equal to 1 plus 4p plus p square by 1 minus p into 4. Now, substituting this value in the above equation 4, that is this equation, we will get the value as 1 plus 4p plus p square by 1 minus p whole square, which is the required value for e of x square. Now, in the first part, we are asked to calculate e of x square minus e of x whole square. Now, we know from b and c, that is from b we know the value of e of x whole square, and from c we know the value of e of x square. Now, substituting both those values here, we will get that e of x square minus e square x is equal to 2p by 1 minus p whole square. In the fifth part of the question, we are asked to calculate the conditional probability mass function for probability x is equal to k given 2 is less than or equal to x less than or equal to 5 when p is equal to 1 by 3. Therefore, we are given probability is equal to p is equal to 1 by 3 and x value is between 2 and 5. Therefore, the probability x is equal to x will be equal to p b into k into p power k minus 1, which is already given. Now, substituting the value of p into this equation of p that we calculated from a, we will get that 1 by 1 minus 3 is equal to 4 by 9. Now, according to conditional probability, we know that probability of a given b is equal to p of a intersection b by p of b. Now, according to our question, we are supposed to calculate probability of x is equal to k given 2 is less than or equal to x less than or equal to 5. Substituting this in terms of conditional probability, we will get this equation. Now, if we write down this equation and substitute the values of p of k and all of that, we will be getting a value which is equal to 1 by 0.577 into 4 by 9 into k into 1 by 3 k power k minus 1 for value of x, which is between 2 and 5. So that is the solving for the first question.